So this section focuses on the next round of fare gate enhancements, building on what is already working and making the gates even better. The enhancement focuses on the 5 areas: stronger gates, better data and communication, improved chime tones, better detection of the piggybacking and tailgating, and object detection. So as you may recall, we already have strengthened all 715 fare gates by adding the mechanical lock that was a part of the installation project. Over the past few months, we also introduced a detachable D-shaped insert shown as the blue bar in the image on the right. So if the insert is damaged, maintenance teams can replace that individual piece rather than repair or replacing the entire fare gate. So what that removable pin or that blue-shaped D-shaped insert does, instead of making it as one single piece of the connection, it's now 2-point connection. So they do not have to remove the doors and the mechanical gears and the motor gears and all that stuff. They can just push that pin and it becomes a 2-point system. So it makes it really easier for maintenance folks to replace the assemblies and the components as needed. We are continuing to strengthen the fare gates in 2 key areas. On the left, we are piloting an enhanced motor gear system at Coliseum and Pittsburgh Center. So this is already at Coliseum and Pittsburgh. The design includes an additional worm gear at the bottom and a larger gear diameter for all the gears, increasing the load capacity and improving resistance to the repeated impacts. The system has successfully withstood 10,000 impacts at approximately 926 pounds. And happy to report, since we implemented this at Coliseum and Pittsburgh Center, we have seen significant improvements to the maintenance concerns at those 2 locations. On the right, we have added gussets at the 10 stations to reinforce the gates, help the doors remain squared, aligned, and more resistant to the impact. So the goal is straightforward here: stronger components, fewer failures, and longer-lasting fare gates. We are also strengthening fare gates at the Bayfair station. The accessible fare gate is currently located on the platform where visibility is limited. We plan to relocate it to the station entrance where it will be easier to monitor and less vulnerable to vandalism and fare evasion. Basically, we are bringing the elevator gate from the aerial structure down to the at-grade level, making it in the line of the sight of the station agent. A 7-foot security fence will also protect the path between the elevator and the relocated fare gates. This work is already progressing and will complete by fall of this year. And this will result in a more secure, visible, and controlled accessible entrance. So we also improved how we diagnose the communication issues between the FareGate software, hardware, and TR4. A compact monitoring computer system was developed and to capture the communication loss. So that is that green rectangle. It's a small PC that we deployed between the TR4 and the S-traffic FareGates, including the hardware and software. And the purpose of that green PC or personal computer was to capture any loss of the communication between the TR4 and the FareGate software hardware assembly. And we did found some of the data loss that was happening. So the FareGate vendor was able to fix that issue, those software glitches and the bugs, and we released a better version of that software on March 31, 2026. We believe it results in the less error messages and enhanced speed of the TR4s and improved the overall data communication because now we are not seeing the messages lost as we were seeing before. We also improved the FareGate audio to make it clearer and more accessible, especially for the riders with a low vision. The original tone was difficult to hear and limited to a basic beep. In March 2026, we introduced a new bell-style chime that is louder, more distinct, and adjustable. Riders can activate it by holding their fare media on the reader for 1 additional second, almost total of 3 seconds. And the result is simple, but it's very meaningful improvement, clearer guidance, and a more accessible rider experience. So this is the improvement on the piggybacking and tailgating. We did the first pilot testing at Antioch and Concord, but we did not advance with that. We learned our lessons, and we did the pilot too, which was deployed system-wide in May 2026, allowing the barriers to close much faster. So accessible gates are at 700 milliseconds, and regular fare gates are at 500 milliseconds instead of 800 milliseconds that was used to be the speed of the gates. The next phase, that is a pilot 3, that's a very innovative and a very rigorous approach we are taking with the software, and that is to engage the overhead bridge analytics, the sensor at the overhead bridge, and talk to the infrared sensors at the consoles, detect the human beings as well as the objects, and make the piggybacking and tailgating, mitigate the piggybacking and tailgating to more effectiveness. So this is still in the progress, and we have to do the rigorous testing of it, as it is a very innovative approach in software, and we will get the software in August 2026. If all the testing goes well, we will release it by the end of this year. This is the object detection. So today the FareGate camera, it's designed to recognize the people, while the objects are primarily detected by the infrared sensors along the consoles. And this enhancement will allow the overhead sensor to identify objects as well, not just the human beings, such as the strollers, wheelchairs, and the luggage, providing an additional layer of protection in the rare cases where infrared sensors may not detect them. So by checking the aisle, the overhead sensor at the top will be checking the aisle every 50 milliseconds. The system can better confirm that the pathway is clear before the barriers close. So the result is a safer, smarter, and more responsive FareGate system. So I will shift to the hardening system, but before I go to the station hardening section, I would like to express our appreciation for the FareGate project manager, Kate Dyson, who is on the left side of mine and who has been very tenacious and a key player for FareGate installation as well as for the enhancement work. Now switching to the station hardening, that is closing the gaps around the fare gates and creating a more secure, controlled station environment. For this, we are advancing two key elements, the barrier installations and the swing gate installation. We developed the 6 mock-ups. We did the 6 mock-ups or the pilot programs. First one was a polycarbonate on the steel barrier. That was basically done when we were doing the FareGate installation itself over the last 2 years to make the system more secure and safe. Second one was a polycarbonate on existing wall at 16th and 24th. The third one was a steel metal mesh fence on the existing wall at 24th Street. Fourth mock-up was a polycarbonate on top of existing barrier at Montgomery. Fifth was a polycarbonate on the steel post, and it just got done at the Embarcadero at MacArthur. And the last one we just did in the MacArthur station, which is a wire mesh on the steel post. So these are all the barrier. The 6 mock-ups were the barriers, not swing gates. And we are exploring all these options and seeing which one is the best fit for which station. So this is the mesh barrier that we already installed at the San Leandro and at the Hayward stations. And as I said at the beginning of the presentation, fare gates and station hardening go hand in hand. The Hayward station photo on the right is a perfect example. The barriers and the fare gates form one seamless full height security line that is 7 feet 4 inches, closing any bypass points while creating a clean, unified station design. We also did the 3 mock-up or the pilots for the swing gates. So one is a polycarbonate that we added to the existing gate at Fruitvale. One was just the metal door frame that we added to the existing door on the West Oakland. And the MacArthur one we just did on the May 2026. That is the entire door and the frame modification. This is a frame that can get the metal mesh or the polycarbonate as we need. This is the example of MacArthur Station. It has a metal mesh barrier. On the picture on the left side represents that, and the picture on the right side represents the swing gate, which is the brand new frame with a metal mesh on it. And MacArthur shows what a fully integrated station hardening station can look like. It was made possible through our strong collaboration with our labor partners. And to conclude the station hardening section, we are now evaluating the best solution for each station based on its specific needs. At the same time, we are advancing the procurement process to secure the materials needed for implementation, and we will come back to the board later this year for recommendation. That concludes the presentation. Happy to answer any questions.